Every spring and autumn, billions of birds push the absolute limits of biological endurance to cross the planet. For a small songbird, the margin for error is razor thin. Navigating storms and exhaustion means that even a minor deviation in heading can lead to starvation or drowning in the open ocean. Humans have tracked these seasonal disappearances for millennia. Ancient civilizations recorded the return of swallows in the spring, observing how creatures so fragile vanished and reappeared with perfect geographic rhythm long before the advent of modern navigation. The physical demands are staggering. A young bar-tailed godwit will launch from the Alaskan tundra and fly non-stop for 7 days and nights, covering 12,000 kilometers of the Pacific Ocean to reach New Zealand. The Arctic tern travels even further, holding the long-distance record by flying from its Arctic breeding grounds to the Antarctic and back again every single year. These species arrive at exact coordinates on opposite ends of the globe, despite crossing thousands of miles of featureless water with no landmarks to guide them. Mapping these journeys originally required researchers to physically catch birds and clip numbered metal bands to their legs. By recording where these specific individuals were recovered, scientists began to see the underlying structure of their movement. These records revealed that global flights are highly organized. Birds instinctively lock onto invisible highways in the sky, known as flyways, routes that stay consistent across generations. This planetary transit network follows the coastlines and mountain ranges of the continents. Massive corridors spanning the Americas overlap with oceanic tracks stretching from East Asia down to Australasia, channeling populations along traditional rest stops. The stakes are highest for first-year juvenile songbirds, who must fly these routes entirely alone. They depart at night, heading thousands of miles to a wintering ground they have never seen, without any guidance from experienced adults. While only 30% of these small birds survive their first journey, those that do succeed rely on a sophisticated, inherited internal navigation system that allows them to return to the same nest box year after year. Birds maintain their heading using a combination of sensory inputs. They possess an internal 24-hour sun compass during the day, and at night, they track the rotation of the stars around the celestial pole. These visual cues are frequently unavailable. Heavy cloud cover can block the stars for days, and birds flying over the open ocean have no landmarks or scents to confirm their position. To maintain a course under these conditions, birds must determine their exact location on a bi-coordinate map. This allows them to correct for wind drift and stay on target even when blown off course. Burke's magnetic field provides the grid for this map. Because the field lines curve and intersect the planet's surface at specific angles based on latitude, they offer a constant, invisible geographical reference. Detecting this force is a significant biological challenge. Earth's magnetic field is incredibly weak. The energy it produces is millions of times too small to break or alter standard chemical bonds. The sensing mechanism is located in the retina of the bird's eye, within a light-sensitive protein called cryptochrome. When blue light hits cryptochrome, it creates a radical pair of unpaired electrons. They begin a rapid quantum waltz, flipping between spin states. Earth's magnetic field lines intersect them, altering this rhythm to determine the exact time spent in each state. This ratio dictates the resulting chemical reaction, triggering the release of neurotransmitters. These signals travel directly to cluster N, the brain's visual processing center. By integrating this quantum information into their visual cortex, birds literally see the magnetic field superimposed over their physical surroundings, using it to chart a course through the dark. A subatomic reaction inside a single protein is what steers living creatures across thousands of miles of darkness. The successful movement of millions of tons of biological mass every year relies on the laws of quantum mechanics operating at the back of a bird's eye. However, this ancient system is now facing a shift it cannot account for. As climate change rapidly alters weather patterns and coastlines, the physical resting points these birds depend on are disappearing faster than the birds can adapt. Vital wetland stopovers, such as the mudflats of the Wadden Sea, are essential for birds to refuel. If these specific locations are lost, the entire global chain of migration collapses. Life on this planet is connected through a scale we are only beginning to grasp. tethered invisibly from the rotation of the stars through the magnetic pull of the Earth's core, all the way down to a quantum waltz in a bird's eye.